In most every new car commercial, there is one word that seems to keep getting more and more attention. This word can be used to promote the latest sports car and its unmatched power. This word is also used to ensure fuel efficiency and economy of small vehicles. This word that is so often used but not properly explained is turbocharger. According to a survey conducted by Ward's Auto, 27.6% of all passenger vehicles in 2017 were equipped with a turbocharger. This is a new record. This massive increase in the production of turbocharged engines leaves many wondering, what even is a turbocharger? Information of how a turbocharger operates is not communicated effectively to the consumers through commercials. This requires the consumers to look elsewhere in order to find that information. Being the car guy that I am, I have a major interest in turbochargers. I've worked on cars for most of my life, fixing them up and learning new things about them. I've even worked on several turbochargers, and I understand the complexities of them. Today, I will explain the fundamentals of a turbocharger and its functions. First, I will begin with explaining how a turbocharger works. Next, I will go over the main parts of a turbocharger. And finally, I will discuss the benefits of a turbocharger. To begin with, I will explain how a turbocharger works. A turbocharger works like an air compressor that is driven by the engine. Now, in order to understand how a turbocharger works, you need to have a basic understanding of how an engine works. Engines work by burning a fuel and air mixture inside of a cylinder in order to drive the piston. Engines suck in this air and fuel mixture into the intake stroke, and then ignite the mixture in the ignition stroke. Once this combustion is complete, the burnt gases are pushed out of the cylinder in the exhaust stroke and through the exhaust. These unused exhaust gases from the combustion are what is used in order to propel the turbo. So how does the turbocharger work? According to Chris Woodford, natural scientist and physics from Cambridge, a turbocharger harnesses those unused exhaust gases in order to force more air into the engine. Inside the turbo, there are two pieces like fans. One fan uses the hot air rushing from the engine in order to propel itself really quick. The second fan is used to suck in fresh air and compress it before sending it back into the engine. This compressed air is then forced into the engine, allowing for a larger combustion. Now, with a basic understanding of how a turbocharger operates, let's take a closer look at the various pieces inside of a turbo. Inside of a turbo, there are three main pieces that make it function. The turbine, the center hub rotating assembly, also called the CHRA, and the compressor. To start, I will go over the turbine. Cummins, a turbo diesel manufacturer, explains that the turbine is considered the hot side of the turbo because it is placed in the exhaust system. The turbine has two major parts, the turbine wheel and the turbine housing. The turbine housing job is to divert the exhaust gases from the engine into the turbo. The turbine wheel's job is to take the energy from the exhaust gas and start spinning at an extremely high rate of speed. The sole function of the turbine is to take the unused potential energy from the exhaust gases and turn it into potential usable energy. In between the two sides of the turbo is the CHRA. The compressor wheel and the turbine wheel are connected to the CHRA on either side of it. This is what allows the turbine to convert its usable energy. The spinning motion is converted from the turbine wheel to the CHRA, and the CHRA converts the spinning motion back to the compressor wheel, giving it the energy it needs to suck in the cold air. The last bit of a turbo is the compressor. The compressor is considered the cold side of the turbo because it sucks in the cool air into the turbocharger system. The compressor has two major parts just like the turbine, the compressor wheel and the compressor housing. The compressor wheel spins and draws in the cool outside air into the turbocharging system and creates a high velocity, low pressure air. The high velocity, low pressure air is then pushed into the compressor housing, which converts the air into a low velocity, high pressure air, or a dense air. The sole function of the compressor is to take in fresh air and compress it before sending it back into the engine. All of the pieces of a turbocharger are important in order to understand how it operates. But why should a vehicle have a turbocharger in the first place? There are many benefits of having a turbocharger on a vehicle. What most are familiar with is the extra power associated with a turbocharger. The turbo pushes this denser air into the engine. The more air and fuel mixture that is being pushed in allows the engine to create a larger combustion. A larger combustion allows an engine to create more power. A turbocharger allows the engine to burn more of the air and fuel mixture at a higher rate than what the engine would be able to by itself. There are limits, though, for how much extra power that an engine can produce, but this varies from manufacturer to manufacturer. The extra power from a turbocharger allows for better fuel economy as well. The use of a turbo does not directly relate to better fuel economy, however. From the law of conservation of energy, in order to create more power, in order to create more energy, you have to put in more energy. According to the Natural Resources of Canada, turbo working at peak efficiency has the potential to save 10% of what fuel you would have used otherwise. But this is not the cause for the drastic MPG difference that we see. The advantage comes from the ability to use smaller, lightweight engines that produce the same, if not more power, than larger alternatives. A smaller turbo inline four-cylinder can be a replacement for a larger V6 or V8 engine, while still having the ability to create similar power figures. This allows manufacturers to produce smaller, lightweight vehicles that get better gas mileage, while still being able to perform similarly to larger counterparts. With the many benefits of a turbocharger discussed, it makes sense as to why turbochargers are becoming so popular with modern vehicles. Today, I have gone over the fundamentals of a turbocharger and its functions. First, I explained how a turbocharger works. Then I described the different parts that are inside of a turbocharger. And finally, I discussed the benefits of a turbocharger. Now, when you see another car commercial talking about how great their turbocharger engine is, you'll be able to truly understand how great it is. Thank you.